Then we come to the SQL injection or SQL. SQL stands for Structured Query Language, which is the de facto language that is used by applications to interact with databases. So let it be a Microsoft SQL database, MySQL database, Oracle SQL. The syntax may be a little bit different, but it is still the structured query language that applications utilize to interact with the database. Now, the queries that are created by the applications need to be sanitized at the application level itself. So developers need to be very careful of how they are going to create those queries, what queries are allowed to go to the database, because a database is designed to answer queries. It doesn't know what is a legitimate query and what is a illegitimate query. If it receives a query, it is going to try to execute it and give out information. Thus, a hacker may insert malicious queries or malformed queries into a SQL server through the vulnerable application, causing a security event. So, depending on the queries that have been created, the attacker could delete some data or modify data, add data, edit it, or do anything that is malicious in nature that would compromise the integrity and the security of that database. For example, the Dunkin' Donuts, right? Except apart from being a credential attack, since they got access to the database, they could have added or deleted any information about any users that were there. As the name suggests, this attack is used to crack or get the password for user's account. When we say crack passwords, this is basically where somebody is trying to brute force or they're trying to guess the password and they're going to break the password, thus getting access to your accounts. There are 5 different ways passwords can be cracked. The first one is a dictionary attack, where we use every password that is possible through the dictionary. Now, this is the use of an actual dictionary, and that's one of the reasons when we try to create passwords, we are advised not to create passwords based on dictionary words, because these are easily guessable and there are lists already out there that contain all of these words. There's a tool that you can utilize, and that tool will then parse through each and every word that is in the dictionary file and then compare it to a possible password. If one of the words matches, the password has then been compromised. So if you are observing a little bit higher security where we have created a password that is not based on a dictionary word, then we want to look at other attacks like brute force. It is a trial and error method. So basically what we do is we identify how the passwords were created. For example, in today's world, the policies would be to consume in a password any of the alphabet characters A through Z, uppercase or lowercase, 0 through 9, and then special characters. And then we want to randomize the usage of these characters so that they are not easily guessable. But a brute force attack at the same time would then try every permutation and combination there is possible in the entire character set and then try to figure out the password. Now, this takes a really long time and does take a lot of compute and storage power. And that's where the botnet example comes back in, the one that we saw earlier, which was used for DOS attack. But similarly, if I've infected multiple computers like this, I can then distribute this attack onto all those computers and use the entire compute power that is available to shorten the time that is required to crack the password. Now, this is 100% successful given the time that it may take. So if the time that is going to take is going to be 100 years, the attack becomes unsuccessful because during that period, the password is most likely to be changed, the technology is going to be changed, and so on and so forth. So if the password is easily guessable, this can be a very easy attack to perform. Then a keylogger, which is a similar attack to what we have seen. So a keylogger, as discussed earlier, is nothing but a software that once installed on your machine would grab each and every keystroke that the user has made and store it in a file which the hacker can later on access. So whatever you have been typing, passwords, credit card information, or anything else, all of those would be recorded and stored in a file, and that's one of the best way a password can be compromised. Then shoulder surfing. This is a physical attack rather than being a technical one. Here you need to physically be present when the user is typing in their password, and you actually look over their shoulder to see what they're typing and try to figure out what the password is. If they're quick typers, it is going to be a little bit more difficult. If they're slow typers, it's going to be that much more easy. And the last one is called a rainbow table. Now, passwords, when applications store them, are stored in hash format. Hash is nothing but a one-way signature that is created of the password file, of the word that is used for the password, and it is based on an algorithm. So the input could be of variable length. For example, a password could be 7 to 14 characters, but the output of a hash value would be fixed based on the algorithm that you're consuming. So most common algorithms in today's world that we utilize are SHA, secure hashing algorithms. Before that, we used MD5 or message digest. So all of these convert the passwords from plain text into a hash value and store it into a database. So if you actually attack that database to grab a password, you're going to get the hash value, not the password in clear text. And thus, in that scenario, comes the rainbow table to the rescue. A rainbow table is nothing but a file that will have the list of all possible passwords along with their hash values in the required format. So if you remember the dictionary attack was nothing but a list of words based on the dictionary that were stored in a file, and then the software was just trying each and every word against a possible password. Here, we do not have the word, but we have the hash value. So to reverse engineer hash value, what we created is, we created a rainbow table where there would be a list of all the possible passwords and their corresponding hash values. So we then compare the hash value that we have captured and then search for that hash value in the file that we have created. The hash value that matches the corresponding word to it is the password in clear text. So these are the 5 types of password attack.